In the search for super cool and clean energy, scientists are buzzing with excitement about something called nuclear fusion. It's like a cosmic party where tiny particles come together, releasing loads of energy, way more than what we get from splitting atoms, which is what we do now. Picture this. We're trying to copy the amazing processes happening in stars to create a powerful energy source right here on Earth. It sounds like something out of a sci-fi movie, but it's real science. Even though it's been a tricky puzzle for scientists for a long time, there's a lot of hope and hard work going on to make fusion a real practical way to generate energy. It's like aiming for a future where we can have lots of energy without harming our planet. Ever wondered what goes down at the atomic disco in the world of nuclear fusion power? Let's find out. Unleashing star power on Earth. In the incredible world of nuclear fusion power, scientists are basically throwing a super cool party for atoms. They heat things crazy high and squeeze atoms at the center, called nucleus, into a wild and free group known as plasma. It's like an atomic disco. Now, in this plasma shindig, atoms get so pumped up that they crash into each other mega hard and fuse their nucleus. This fusion dance releases a massive amount of energy in the form of heat. Just imagine. It's like getting super hot steam to spin turbines and create power, just like our regular power stations, but way cooler. Two hydrogen pals, deuterium, found in seawater, and tritium, made from lithium in nuclear fission, team up, fuse, turn into helium, and boom. Loads of energy to light up our world. And guess what? There are different styles to make this fusion jam happen. It's like science fiction becoming a science reality. Magnetic confinement fusion, MCF. Picture this, a futuristic donut-shaped chamber called a tokamak. What happens inside is pure sci-fi brilliance. Powerful magnetic fields step up to the plate, turning into fusion guardians. They lock in super hot plasma, preventing it from touching the walls and losing its fiery essence. It's like creating a sizzling fusion stew without letting the heat escape. To keep this plasma party rocking at extreme temperatures for as long as possible. Think of it as conducting a symphony of magnetic forces, all to master the art of fusion magic. Inertial confinement fusion, ICF. Mini fuel pellets get the superstar treatment with powerful lasers or particle beams. It's like they're in a sci-fi spa, getting compressed and heated in the blink of an eye. The pressure applied is so intense, it's like the ultimate squeeze, causing the outer layers to burst inward. This compression dance kicks off fusion reactions, creating a tiny hydrogen bomb moment. But hold on, it's all controlled and scientific. Make sure this compression hug is super even, and that the energy delivery to the fuel is as smooth as butter. Magnetized target fusion, MTF. A magnetic field swoops in like a superhero, giving a warm hug to a magnetized plasma. At the same time, a plasma buddy or a high-energy particle beam jumps into the party, adding some heat and making things sizzle. It's like the ultimate fusion dance-off, aiming for temperatures and densities that scream, "Let's fuse." This fusion trio, known as MTF, is still in the experimental lab, where scientists are fine-tuning the moves for the hottest fusion party in town. Dense plasma focus, DPF. All right, let's dive into DPF, the fusion world's electrical showstopper. Picture this, a fusion party where we use a jolt of electricity to create a super hot plasma. Our main performer. This electrically charged party animal gets compressed, heating up even more and sparking fusion reactions. Now, DPF devices are like the compact, easy-to-set-up entertainers of the fusion world. Clean energy marvel or distant dream? All right, let's talk about fusion power, the superhero of clean energy. Here's the cool part. It produces zero carbon emissions. Imagine a party where the only leftovers are tiny amounts of helium, totally harmless to the environment. Plus, it's a champ in efficiency. According to the brainy folks at the Cullum Center for Fusion Energy, 1 kilogram of fusion fuel can match the energy of a whopping 10 million kilograms of fossil fuel. Now, fusion often gets mixed up with its cousin, fission, but guess what? Fusion is the cleaner, safer sibling. It leaves no radioactive waste behind. Only the reactor parts get a bit of radioactivity makeover. Forget large-scale nuclear disasters. Fusion reactors are like the superheroes that dodge those troubles. The EU's fusion power project is eyeing the stage in 2050. But here's the twist. Making fusion happen is like solving a mega puzzle. While tech wizards make strides, it's still a work in progress. Also, we're low on tritium, a fusion fuel player. Future reactors might produce it, but for now, our fusion tests are rolling with deuterium. A green energy revolution on the horizon? People worldwide are investing billions to make fusion a superhero in our clean energy gang. The Fusion Industry Association spilled the beans in its 2022 report. Fusion companies bagged over $4.7 billion in private funds and an extra $117 million from governments. Hold on, in 2021 alone, they snagged a whopping $2.83 billion. Private players like Tokamak Energy and Helion are zooming in to beat government projects to the fusion punch. Who'll nail it first is a mystery. But with these billions rolling in, private champs might just grab the glory. Despite fusion puzzles, the vibe is optimistic. The FIA report spills the tea. 66% think fusion power plants will light up the grid by 2035, and 60% bet on fusion becoming a hot, marketable energy source by then. As we sprint toward a cleaner energy era, nuclear fusion stands tall, waving the flag of a carbon-free, resource-friendly future. Sure, obstacles are there, but the fusion quest? Now that's a story of human smarts, science leaps, and the unstoppable quest for a brighter, greener tomorrow. In the dynamic pursuit of cleaner energy, nuclear fusion emerges as a promising solution, resembling a cosmic dance of atoms to power our world. Despite its challenges, from magnetic confinement to laser-fueled compression, fusion represents a superhero of clean energy, producing no carbon emissions and demonstrating remarkable efficiency. Fueled by billions in private and government funding, the industry envisions fusion lighting up the grid by 2035, reflecting a collective commitment to a greener future. As science meets optimism, nuclear fusion stands poised at the forefront of a revolutionary era, embodying human ingenuity and a relentless quest for sustainability. So that's all for today's video. If you like this video, click the like and the bell buttons. We'll have another video for you soon. Take care until then.